Hello, good people. Welcome to this series. And the focus of this series of videos is to show you how to use Matplotlib as a data visualization tool in Python. And I plan to make it as straightforward as possible. So I also want to appeal to people on different operating systems, especially those on Windows who usually have issues setting up certain Python libraries and stuff like that. So in order to save you from all those hassle, I'm going to use Colabs, and you can access it by going to colab.research.google.com. And basically, Colab is a Jupyter notebook server that has been hosted on Google machines in the cloud, free of charge for everyone to use. Okay, so you go to collabs.research.google.com and then you click on new notepad, and you basically have something that looks very similar to Jupyter notebooks that you will set up on your computer. But the good thing is that now you don't need to set anything up. It is already hosted for you on Google servers, and then you can do almost anything that you want in here. And the good thing is that it also ships with a free GPU machine. So if you're doing any serious machine learning stuff and then you need GPU to crunch on data, then you are free to change the runtime. But because we are going to concern ourselves with just rendering simple graphs, we are not going to use any GPU in this course. Okay, great. So if you want to know how to set up Jupyter notebooks and other Python related stuff on your own, then I will encourage you to watch my Mastering Deep Learning playlist on YouTube, because over there I show you how to create virtual environment and set things up, and how to install your own Jupyter and start your Jupyter server and get this an interface that looks similar to this. But I just want to make it easy for everyone to get started, so I'm just going to use Jupyter Notebooks hosted Colabs, which is hosted by Google. So I'm going to name this lesson 1. I'll just name this lesson 1. Okay, so in this lesson, I'm just going to show you how to import Matplotlib and then plot some very basic graphs, and just to give you a taste of what's possible, and then subsequent videos will get us more into advanced stuff. Okay, so I'm going to start by importing NumPy as NP, and once again, if you don't know about NumPy, I will encourage you to watch the Mastering Deep Learning videos. There are sections in there where I treat NumPy specifically, and we don't need NumPy in totality to use Matplotlib, because Matplotlib can also work with regular Python lists. As you will see in this video, I'll just be using regular Python lists, but as things get complex, I will be using NumPy. So that's why I'm importing it. And then by convention, we also like to import Matplotlib as PLT. We alias it and call it PLT. So import matplotlib.pyplot as PLT. Okay, now before we start, I'm going to enter some code in the next cell, and then I'll explain what it does. So basically, Matplotlib doesn't ship with its own backend for rendering the graphs. Instead, it uses some backend graphic libraries that is dependent on the operating system on which you are using Matplotlib, and so we are free to switch the graphics library that it uses to render the graph. But in Jupyter notebooks or Colabs, and by the way, when I say notebooks, I mean notebooks, Jupyter notebooks, whichever notebooks you are using. So in notebook settings, we like to let the graphs render automatically once we plot them in the next cell without necessarily having to call show. So Matplotlib graphs have a function called show, which you always have to call, especially on desktop environment. And what's going to happen is to open your graph in a window, but in a Jupyter notebook setting, we are viewing things in the browser. So the next line that I'm going to type will make it possible for the graphs to render automatically once we plot them without necessarily having to call show on them. So I'm going to say Matplotlib, and take note of the percentage sign that is over there, is a magic thing. So Matplotlib inline, okay, and I'm going to execute this. Okay, so now we have everything set up. Let's create a simple Python list and plot it. Okay, so I'm going to create data, and I'll put in the, let's say 1 4 2 7 3 9 5 2 6 1 0. So basically I'm just using these numbers arbitrarily. Okay, now I have created a regular Python list. This is not even a NumPy array, it's just a regular Python list. What's going to happen is I'll say plt.plot, and then I'll give it data, and let's see what's going to happen. Okay, so once I call plt.plot, you see that it has plotted the data that I have in the list. And you may be wondering, which axis did it plot this data on? So if you call plt.plot and you give it just one list, or you give it just one argument, you give one argument, which is the data we have here. If you give just one argument to the plot function, that what's going to happen is it is going to plot it on the y-axis. So you can see that the first entry here, which it has automatically assigned indexes to, and the way it does that is uses the index of each of the entries in the list as the x-axis value. Okay, so it says at index 0 the number there is 1, and then it comes to index 1, which is 4, and then you come to index 2, which is 2, and then it comes to index 3, which is 7, index 4, which is 3. So it basically uses the indices of each of the entries in the list as the value on the x-axis, and then what you actually put in there, what the item in the list itself becomes the value of the x-axis. Okay, now what if you want to actually provide value for the x values and then for your y values? Okay, so what's going to happen is, let's create our x values. So I'm going to say x values is equal to I mean, it can be anything, it can really be anything. So I'm going to choose random numbers that comes into my mind. Okay, so I have let's say 1 3 6 9 4 and then 5. I mean, so then I'm going to create the y values, and the y values is also going to be equal to, let's say 2. But by the way, the number of items in your x values should be equal to the number of items in your y values. Okay, so 2, and then I'm going to plot this, and I'm going to plot maybe this, and maybe this, and let's put 0. Okay, so I'm going to plot. I'll say plt.plot, and then I'll plot my x values. So this time I am explicitly stating what has to go on my x-axis, and then I'm also going to state what has to go on my y-axis. Okay, now if I do this, you can see that it has plotted the graph for us. It is not a very nice looking graph because I chose things randomly, but what it basically means is that the first point here, the x value is 1. So you can see that this is 1 on the x-axis, and then 2 on the y-axis. So that is where they meet, and that is how come it plotted it over here. For the second, you can see that the x-axis, the value is 3, so this is 3, and then the next number on the y-axis is supposed to be 5. So you can see that it is just like plotting things on your regular Cartesian plane that you know about in basic trigonometry or algebra from college mathematics. Okay, so this video is just meant to give you an introduction to what you can do with Matplotlib, and I believe already you see how useful this is. Okay, so we can plot. How about we scatter? Okay, so I can also say plt.scatter, and that is going to give us a scatter plot. So I create a scatter plot and specify the x values and my y values, and let's see what's going to happen. So over here, instead of drawing a line, I mean through the point, it just places the point on the Cartesian plane, and that is it. So the difference you need to note here is that plot actually draws a line through the point, and then scatter is just going to place the coordinates on the Cartesian plane, and that is it. So thank you very much for watching this, and I'll see you in the next video.